Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, this lecture based on to find the solution of a linear differential equation of second order or third order with constant coefficient. What in a linear differential equation with constant coefficient, in right hand side q is given. That is very must. Q is some function of x and q is given in our question. So this is special case. The value of q in the given differential equation is standard type of function. So which type of function we are discussing here? Q is, in Q there are two functions. One is exponential function, other is trigonometrical function or algebraic function. Both functions are in multiply. Then here we want to discuss how we can find particular integral of this special cases. So here we want to discuss case 6 and case 7 one by one. Now case 6 and case 7, here we will discuss of linear differential equation of second order with constant coefficient in standard form. Here q equal to, standard value of q is here, q equal to e to the power ax into b. In q there are two functions, both are in multiply. First is exponential function e to the power ax. This is very compulsory function in both cases. And second one is v. V is either trigonometrical function sin vx or cos vx or algebraic function x to the power n, where a and v are constant. Both may be positive or negative. But n is always be positive. So sin vx or cos vx, how we can say that b is always positive or negative? So here we discuss here, we know that sin, here sin minus theta. If trigonometrical function sin, if there is angle minus theta, then we have formula sin minus theta is equal to minus sin theta. So here is b's number is negative. Suppose sin minus 2x. Then we write here minus sin 2x. So no problem. Here minus is occurs here. And similarly for cos, cos minus theta equal to plus cos theta. Here is plus sign. So here, so we have sin minus 2x equal to minus sin 2x and cos minus x equal to plus cos x. So here we can say that a and b both number may be positive or negative, no problem. But in algebraic function, the x to the power n is any number, but n is always a positive integer, positive number, natural number is a positive number. So here general differential equation for case 6 and case 7 is given as follows. Which is the general equation? So we want to discuss what is the general differential equation of second order with constant coefficient. So here d2y over dx2, here is multiply by 1 plus dy dx multiply by p1 and into y multiply by p2 equal to e to the power ax, this is exponential function, into b. B is some function. B may be trigonometrical function or algebraic function. But first function is very must to be an exponential function there. So here P1 and P2 both are constant. So P1 and P2 are constant means P1 and P2 are in multiply with derivative. So P1 and P2 are constant. So we can say that equation 1 is known as a constant coefficient. But in right hand side, q is given. Q is here e to the power ax into b. This is standard form of q. Here first function, this is function f1 and this is function f2. f1 into f2. f1 is e to the power ax. This is exponential function. Exponential function. And f2 is v. So b is trigonometrical function. Sin ax or cos ax. Trigonometrical function. Or v is x to the power n here. So b equal to sin ax or cos ax or x to the power n. Here may be any one function. First function sin ax, next is cos ax, next is x to the power n. But here q equal to, we taking here e to the power ax and sin bx into. This is exponential function and this is trigonometrical function sin bx. A and b are number here. E to the power ax next one into cos bx. In this function also a and b are number. Last is e to the power ax into x to the power n. Here a and r number. In each three cases here we see that exponential function is common. In all function exponential function is common. E to the power ax is very must in our given question. Next is b. b may be sin bx, b may be cos bx, b may be x to the power n. So how we can solve these if q is given this type of function? So here we want to discuss each cases one by one. So here now in case 6, first of all we want to discuss, in this lecture we want to discuss the case 6. So we will discuss about the following given standard differential equation. So here d2y dx2 plus p1 dy dx plus p2y equal to e to the power ax sin bx. Here two functions are there in q. This is total q. In q is two function e to the power ax sin bx. E to the power ax is exponential function, sin bx is trigonometrical function. This is equation 2. Second one is d2y dx2 plus p1 dy dx plus p2y equal to e to the power ax into cos bx dx. So e to the power x, exponential function in equation 2 and 3, both is common. But second function is either sin bx or cos bx. In trigonometry function, we are taking only two function here, that is sin bx or cos bx. Here a and b are both are positive or negative. In case 6, we have seen in our question that a and b are both positive or maybe negative. So now in case 7, we will discuss about standard differential equation that is given as follows. That is given as follows. Given as follows. d2y over dx2 plus p1 dy dx plus p2y equal to e to the power ax into x to the power n. Here also we see that e to the power ax is exponential function into x to the power n is algebraic function. Means in R 2, 3, 4 equations we see that exponential function is common. What v is here algebraic function. V is change. In case 7, V is change. First function is no change, e to the power x. V is change here. V is x to the power n. V is here x to the power n. So V is change. Here A is maybe positive or negative. A is the number in exponential function. N is the number in algebraic function. So here A may be positive or negative number, but n is always be positive. N is never negative. If n is negative, suppose if n is negative, then x to the power n is rational number. The power is rational. So that is not exist here. Now in case 7, n is only positive number here. So first we discuss the case 6 here. Now in case 6 and 7, both cases, we will discuss about the method. Same method apply in case 6 and case 7. Same procedure we apply here. So here we want to discuss what procedure we are applying in our question to solving the problems. So that method which is applied in given standard differential equation I am discussing here. So here D is derivative, differential with respect to x. D means d over dx. That is differential with respect to x d. So that is q, dq. Here d, dq. Q is the function. D means derivative of function q. Q is here this. Here q is e to the power ax into b. So now we want to differentiate this function. So differentiation of e to the power ax into b. Here we apply product formula. First function f1 and second function f2. So differentiation of e to the power ax is constant. We are taking first function constant. Differential of v means dv. dv means differential of v with respect to x because v is the function of x here. Plus v constant, differential of e to the power ax. We apply here product formula. Product formula is apply here. Product formula of differentiation apply here. Formula of differentiation apply here. So here derivative of f1 into f2, this equal to f1 d of f2 and plus f2 d of f1. So this is the basic formula, product formula between two functions. So differentiation formula we apply here this. So same formula we apply in this line. So here exponential function is first function, we are taking constant here. Differentiation of second function b with respect to x, so here is dv plus b is constant, second function is constant, differential of first function d e to the power ax. So here e to the power ax dv plus b, differential of e to the power ax, that is a e to the power ax. Differential of d of e to the power ax is a e to the power ax. This is differentiation. We are seeing here e to the power ax is common. That is in multiply in both function. So exponential function taking common. Then we get here dv in bracket, we get here dv plus ab. A is constant and b ab. But dv, b is here differentiate with respect to x here. So dv. So b taking in common in right side. So dv plus ab. Now b taking common here right side, not taking this left side common because here is dv. dv means differentiation of b with respect to x here. So this is operator. D operate to b. So here d is operator of v. So b taking right hand side common. So here b is common. So what will happen in equation 5? We differentiate q one time, then we get here e to the power ax d plus ab. Means in left side we are getting here e to the power ax. And right side we getting here v. And middle here we get d plus a. Derivative here is derivative d convert in d plus a. So this is basic concept here. If we multiply, differentiate two functions which are in multiply, then first function exponential taking left side and other function taking right side, and in place d, we write here d plus a. This is conclusion. Now similarly, we differentiate two times here. D square of this is q. So we write here d square and q. What happened when two times differentiate of q? So q is e to the power ax into b and d square, second time derivative of this function. So we write d square d into d. D into d means d square. D into d means d square. So I am breaking here d square d into d. This is q. This is q here. E to the power ax into b. So one time differentiate here. Last equation we have discussed this. E to the power ax dv plus v d e की power ax. So differentiating of exponential function, Again differentiating this function differentiates, so d e to the power ax db plus here differentiate b d e की power ax. So again product formula apply in this bracket. So first function is constant e to the power ax, differential of dv here d square v, and plus dv is constant, differentiation of e to the power ax a e to the power ax. Now in next bracket again apply formula here, v is constant, putting here b constant, differential of d e की power ax. So here we get d square e to the power ax, and plus d e की power ax constant, differential of b is dv. So now here e to the power ax d square v, a e to the power ax dv, and plus b d square, 2 times differential of this exponential function d square of e to the power ax. So we write here a square e to the power ax. So we get here a square e to the power ax, and dv, this dv, differential one time of this. So d e to the power ax is a e to the power ax. So we write here a e to the power ax. So this term is and this term both are same here. A e to the power ax, a e to the power ax dv dv. So we are adding these two terms. So we get 2a e to the power x dv and plus b a square e to the power x. Here e to the power ax d square v. What will be happen? E to the power ax is common here function. This is in multiply in each term. So we can take common e to the power ax. E to the power ax taking common here. What will happen here? Here d square v plus 2a dv plus a square v. Now here b is differentiate with respect to x, here this term one time and this term 2 times. So d operating b. So b taking right hand side common, never taking left side. So if you are taking b left side, then your question is wrong. So here b is taking right hand side common. So we get here d square plus 2ad plus a square. So this is d square and plus 2ad and plus a square. So this is perfect square. This is d plus a ka whole square. So we write this equation a square plus b square plus 2ab. This identity apply here. Then we get d plus a ka whole square. So now next d square of e to the power ax into b. This equal to e to the power ax and d plus a ka whole square into b. So what is conclusion of equation 7? We discuss here. If 2 times differentiate of this q, in q is 2 function f1 and f2. So we see that finally we get here exponential function is left side in multiply and v is right side and d here d square. So d square, here is writing d square. We write here d plus a ka whole square. So this value putting here. So d plus a ka whole square. This is the conclusion. Similarly, we can show that next result which is given as follows. In third equation is d cube of this function q. This is q function. 3 times differentiation of q. Then we get same. Exponential function is left side and v is right side. This is left side L. This is right side R. And d plus a ka whole cube. If we differentiate 4 times of q, then same procedure here apply. E to the power x taking left side, b taking right side, and d plus a ka whole 4. So in this case, we find out the result finally. Exponential function e to the power x taking to the left side of particular integral and putting d equal to d plus a in denominator of pi, not putting in numerator, only in denominator putting d equal to d plus a. After applying this method, we can apply case 4 and 5. We have discussed already case 4 and 5, which we have already discussed in last lectures. So problem 1 based on case 6. We have taken here one problem, how we can solve. We can apply the case 6 in this question. So we discuss here. This is problem 1 based on case 6. Solve d2y dx2 minus 7dy dx plus 10y equal to e to the power 2x into sin x. So this is q equal to e to the power ax into b. b is sin x here. So here q e to the power ax is e to the power 2x and v is here sin x. Okay. So solution start. Now this is d2y dx2 minus 7dy dx plus 10y equal to e to the power 2x into sin x. We have taken this equation as a 1. So this equation is known as a linear differential equation of second order with constant coefficient, because here is number 1 multiply, here is 7 multiply minus 7, here is plus 10y. So here all numbers are there, no variable is there. In our question there is no variable. So this is known as a all numbers are there, all constant are there. So this equation 1 is known as a linear differential equation of second order with constant coefficient. But in right hand side there is q. In this q there are two functions, both are in multiply into. So first function is exponential function and other function is trigonometrical function. So e to the power ax into b. So we discuss here, equation 1 can be written as, this equation can be in differentiation form. What is differentiation form? d over dx represented by d. d2 over dx2 represented by d square. So we can write here 2 time differential, that is d square, 1 time differential, that is d. So d square minus 7d plus 10. Y is common to all on right hand side. Here y cannot taking common left side. Always be taking y common to right side. If you are taking y common as a left side, then question 100% wrong. So y is right hand side common because y is differentiate here. If you are taking this left side, so that is out of differentiation. So question 100% wrong. So e to the power 2x into sin x, this is equation 2. Means equation 1 can be written in d form, differentiation form. So here q equal to e to the power 2x into sin x, this is equation 3. Now solution of equation 2 in two part. Solution of equation 2 in two part, because q is given here. If q is not given here, then there is only one part of the solution, that is known as a CF. If q is given in our question, then there are two part of the solution, that is CF, complementary function, first solution, and second solution is particular integral. When we finding complete both solution, then we find complete solution of the given question. So now here first we will find CF of given question. To find CF, how we can find CF, we have discussed in from last videos, how we can find complementary function here. So to find complementary function, putting q equal to 0. First of all, right hand side must be 0, then we can find CF. So q0 in equation 2. Then we get here, what we get here? d square minus 7d plus 10y equal to 0. This is equation 4. Where fd, what is fd? Fd is function of d. Means any relation is only d. These are the fd, d square plus 5d and plus 6. This is fd. Another fd, d square plus 4. This is fd. So these are all known as a equation as a fd. So fd is, where fd is d square minus 7d plus 10. This is equation number 5. Because when we find out the particular integral, then we find the function of d only. So we write here this equation 5. What is fd in our question? Now 4, in 4 putting d equal to m. This equation is 4. So we find an auxiliary form of 4. When we find auxiliary form of 4, then we find roots of 4. Roots of 4, then we find CF of 4. So now 4 putting d equal to m and removing y from equation 4. Then we get an auxiliary form of 4. This is 4. So this is an auxiliary form of 4. Here putting m square minus 7m plus 10 equal to 0. Putting d equal to m in 4 and y removing from 4. Then we get equation this 6. So now factorizing of equation 4, finding value of m. Here equation 6 is quadratic equation. We can factorizing this. So now here m square minus 7m plus 10 equal to 0. So 10 is, factor of 10 is 5 multiplied by 2. And here is 7. So this is plus 10. So 7 is 5 plus 2. So this factor are applied here. So minus 5 plus 2m plus 10 equal to 0. M square minus 5m minus 2m plus 10 equal to 0. Here taking m is common, then m minus 5 minus 2 common, m minus 5. M minus 5 both bracket are same here. So again taking m minus 5 common. Next bracket we get m minus 2 equal to 0. If m minus 5 is 0, there are two factors in this result. After factorizing we get two factors. Both factors are in multiply. First of all we taking first factor equal to 0. Then we find m is 5. And again equating second factor equal to 0. M minus 2 equal to 0, it means m equal to 2. So in 7 equation we find value of m. Here we get roots of an auxiliary form. Auxiliary form 4, m equal to 2 and 5. M equal to m1, that is 2. M equal to m2, that's it 5. Two roots. So here roots of an auxiliary form are different. Here different roots, 2 and 5, roots are different. So we apply here formula for different roots. Which formula applied when roots are different? So formula is this here. C1 CF equal to C1 e to the power 2x plus C2 e to the power 5x. This equation 8. We write here formula for CF. C1 e to the power m1x and plus C2 e to the power m2x. This is formula for CF when roots are different. So m1 is 2 and m2 is 5. Putting value of m1 and m2 here, then we get equation 8. This is the complete CF of equation 1. So here finding second part of the solution, that is Pi. Now this is first part of the solution of equation 1 is complete here. We find the complementary function. Now here we find second part of the solution, that is Pi. We use here formula for Pi. So which formula? Apply for finding Pi here. This is very important formula. Pi is equal to, Pi means particular integral. Particular integral 1 upon fd. 1 upon fd. Fd means function in d into q. This q is in numerator. So this equal to 1 upon fd into q. I am putting value of q here. E to the power ax into v. This equation 8. Now this equal to, here we apply same formula which we are discussing already. Exponential function taking left side and putting fd. D equal to putting here d plus a. So here d plus a, fd plus a, and b is right hand side. So this is general concept of finding Pi for this case. Case number 6. Value of q from 3 and fd from 5, putting in equation 8. Then we get in 8 equation, first of all we putting the value of fd and putting the value of q here in our question. So in our question, what is fd? Fd is d square minus 7d plus 10 from equation 3. And this is q, e to the power 2x into sin x. This is equation 9. Rule 1. Here, what rule we apply to finding Pi, particular integral? We have discussed in case 6, if q is e to the power ax into b, both function are in multiply, then e to the power ax is exponential function. In q, this is taking to left side of Pi, particular integral. exponential function taking left side in multiply of pi, and in numerator b taking to right hand side of pi, b putting right hand side, exponential putting left hand side of pi, particular integral. Both are in numerator, and putting d equal to d plus a. I have already proved here. D equal to putting d plus a in denominator, not in numerator, in place of d of pi. Then we get here. Okay. So we get this equation. Particular integral equal to e to the power 2x. I am writing e to the power 2x exponential function to the left side in multiply of pi. This is pi. And here I am writing fd. So here putting d equal to d plus 2. A is here 2. A is 2. So d equal to d plus a. D plus a means d plus 2. So d equal to d plus 2. D plus 2 ka square. In last equation this. Here d square minus 7d plus 10. In this equation putting d equal to d plus 2. D equal to d plus 2. Only place of d putting d plus 2. So I am putting here, finding this d plus 2 ka whole square minus 7d plus 2 plus 10 and sin x. This is v and this is exponential function. So here this is out of integration. This is comes in answer. No change in this function. But we change here because this is differentiate or integrate. So e to the power 2x, opening this square, whole square, d plus 2 ka whole square. So what is d plus 2 ka whole square? D square plus 4d, a plus v ka whole square. So d square plus 4d multiply by minus 7 minus 7d minus 14 and plus 10. So plus 10 and plus 4, 14, that is cancelled by 14, plus minus. 14 minus 14 is equal to 0. So here 7d minus 4d. So here is minus 3d. So at last I am finding the e to the power 2x 1 upon d square minus 3d into sin x. This equation number 11. So in last cases we have already discussed that if there is trigonometrical function sin ax or cos ax, then putting d square equal to minus a square. Minus a square means this is v square. V is here 1. So v is here 1 here. V square is 1 square here. Means minus 1. So formula B have discussed in case 4. You check again case 4. What we are doing when trigonometrical function sin ax or cos ax is there. So here I am writing here d square. D square is minus 1 here. D square equal to here putting minus 1. So here is, this is wrong here, minus 1 ka square. So here is minus 1. So here is minus 1 means minus is common, 3d plus 1. Okay. So now multiply by 3d minus 1 in numerator and in denominator. Multiply its conjugate 3d plus 1 and 3d minus 1. This minus 1. Multiply 3d plus 1, 3d minus 1 in numerator and in denominator. So we get here 3d minus 1 and here is 9d square minus 16 minus 1 here. This is 1 only, not this. So here is again putting d square equal to minus a square equal to 4. So not again 4. Here is sin ax, sin is vx, that is sin x. So here is v is 1 here. So I am putting here v, this is wrong. I am putting here d square equal to minus 2 square, that is wrong. So here is 1 only. So now here putting 1. So here is 3d minus 1 and upon here is what number here? 9 minus 9 minus 16. 16 9 25. So plus 25 is there. Here is 25. 25 here. Sin x. Now taking sin x in bracket in numerator of pi. This sin x multiply in this bracket. So here multiply 3d sin x minus 1 sin x and into 25. So here is 3d sin x. Differential of sin x. Differential of sin x is cos x. So 3 cos x Differential of sin x is cos x. 3 cos x minus sin x. So this is pi. Okay. So now here equation 15 is complete pi of 1. Now complete solution of 1 is y is equal to cf plus pi. So this is y is equal to, not this is y is equal to c1 e to the power 2x plus c2 e to the power 5x plus e to the power 2x. This is pi and this is cf. Total solution equal to y. So 3 cos x, not here 4, and here is 25. So this is complete solution of given question 1. Now problem 2 based on case 6. In our first problem we have taken as, but here taking cos x, here sin x. So problem 2 here, problem 2 based on case 6 again. So here is again d2y over dx2 minus 4 dy dx plus 13y equal to e to the power 2x into sin x. So here number is changed but question is same here. So solution d2y over dx2 minus 4 dy dx plus 13y equal to e to the power, question is this here cos 3x. This is not this sin x. E to the power 2x and cos 3x. Okay. So now here solution d2y over dx2 minus 4 dy dx plus 13y equal to e to the power 2x cos 3x, not sin here, cos 3x we have taken here. So this equation is 1. Equation 1 can be written as, this equation can be written as d form. d over dx putting capital D. So d square minus 4d plus 13y equal to this equation 2. And q is, where q is e to the power 2x cos 3x. This equation 3. Solution of equation 2 in two part because q is given here. First solution is cf and second solution is pi. First solution is cf. So now here first we will find cf, complementary function. To find cf, putting q equal to 0 in equation 2, then we get. So here d square minus 4d plus 13y equal to 0, this equation 4. Where fd, this result is known as a fd. Where fd is d square minus 7d plus 10, this equation 5. Now in 4 putting d equal to m. Now in equation 4 putting d equal to m and removing y from 4, equation 4. Then we get an auxiliary form of 4. When we find an auxiliary form of given question, then putting d equal to m in our question 4 and y removing, because y is our answer. Y is answer of our question. So y is never 0. So y removing here and d equal to putting m. So we get an equation of second degree in m, that is known as a auxiliary form. So here auxiliary form of 4, m square minus 4m plus 13 equal to 0. So now factorizing equation 4, finding value of m. We know that equation 4 is a quadratic form. This equation 4 is a quadratic form. Equation 6 is a quadratic form. 6 is a quadratic form. Now we know that equation 6 is a quadratic form and ax square plus bx plus c. This is general equation of quadratic form, that is equation 7. So comparing equation 6 and 7, then we get value of a, b and c. A is 1, b is minus 4, c is 13. Apply Sri Dharacharya formula to solving equation 6. Dharacharya formula is m equal to minus b plus minus under root b square minus 4ac upon 2a. This is general formula to find any quadratic equation, any 2-degree equation. We find two roots from this formula. This is given by Sri Dharacharya. So now I am equal to putting here minus b P is minus 4. So here is plus 4. Plus minus under root B square. Minus 4 ka square. Minus 4, A is 1, C is 30. So here is 4 plus minus. Minus 4 ka square plus 16 minus 13 4 ja 52. Upon 2A. 2A 2 into 1. So 2 only. So now 4 plus minus under root here minus 36. 12 minus 6 is 6. 4 minus 1 is 36. Upon 2. So 4 plus minus under root minus 1 and under root 36 upon 2. So I am equal to 2 plus minus 36 ka 6. Be right here 4 plus minus under root I. Here is 6 upon 2. Divide by 2. 2 3 ja 6. 2 2 ja 4. So we get here 2 plus minus 3i. I is under root minus 1 or I square is 1 here. I square equal to putting minus 1 and I equal to under root minus 1. In root minus 1 we can put I. So we get here imaginary roots of an auxiliary form. So basically these roots are in this form, alpha plus minus I beta. So alpha is 2 and beta is 3. Roots are an imaginary form. So formula, using formula for CF if roots are imaginary. So CF equal to e to the power alpha x C1 cos beta x plus C2 sin beta x. This is equation 9. So CF equal to alpha is 2, putting here e to the power 2x and beta is 3. C1 cos 3x plus C2 sin 3x. This is equation 10. Equation 10 is complete complementary function of question 1. Here finding second part of the solution, that is Pi. We use here formula of Pi, particular integral. Which formula we apply here? In last question, same formula we are applying here. So Pi equal to 1 upon Fd into Q. 1 upon Fd into Q. Q is e to the power ax into b. There are two functions in multiply in Q. First function is exponential function, second function is b. This is equation 8. So e to the power ax taking left side and b taking right side, and in place of fd, d equal to putting here d plus a. So here is fd plus a. This is basic concept to find Pi. Same rule we apply in our question. So value of q from 3 and fd from 5, putting in equation 8. 8 is this equation. So here fd, d square minus 4d plus 13 and this cube e to the power 2x into cos 3x. One problem based on sin bx and second problem based on cos bx. So these two problems are based on, in case 6, and different trigonometrical functions, sin bx or cos bx. So rule 1 apply here. We have discussed in case 6, if q is e to the power ax into b, there are two functions in Q. First is exponential, other is trigonometry. Both are in multiply. Then exponential function taking left side of Pi in numerator. This is clearly I am writing here. So you remember it. If there are two functions, first is exponential, other is trigonometry. Both are in multiply. Then exponential function taking left side, and other function trigonometry taking right side of Pi in numerator, and putting d equal to d plus a in fd in denominator of Pi only, not in numerator, only denominator Pi. So now Pi equal to e to the power 2x, this is left side, and 1 upon d plus 2 ka square, d plus 2 and 13 cos 3x. So here squaring on both sides, e to the power 2a, d square plus 4 plus 4d, multiply by minus 4 minus 4d minus 8 plus 13. Here is cos 3x. Cos 3x here. Here is not sin x here. In our question is cos 3x. I am taking here sin x. No problem. Be taking here sin x. So here is in last line, here 4d is cancelled. And 13 or 4, 17. 17 minus 8 is 9. So question is this, d square plus 9. What here function is sin x here. So sin x means b is a. A I am taking here 1. If I am writing here sin x, then this question is correct. So putting d square equal to minus a square equal to minus 1 square. So e to the power 2x, putting d square equal to minus 1 square plus 9. So particular integral e to the power 2x 1 by 8 into sin x. This is 12. Okay. So equation 12 is complete PI. Equation 12 is complete PI of 1. So now complete solution of 1 is y equal to CF plus PI. Now adding equation CF and PI. Then we get this is CF and this is PI. So now equation 13 is complete solution of 1 of the question. But here we are taking here sin x. This, you remember this, here is sin x. Then our answer is this correct. If there is cos 3x, suppose I am writing here. Now we have given here some problem based on case 6 for practice. You can solve this question self. So problem 3 based on case 6. So here d cube y over dx cube minus d square y over dx square minus plus 3 dy over dx plus 5y equal to e to the power x cos x. So this question, this is suppose question 1. You can write here d cube minus here d square and plus 3d and plus 5 into y equal to e to the power x cos x. So first of all, you take this result taking 0. D cube minus d square plus 3d and plus 5 into y is equal to 0. I am putting q 0. So now putting d equal to m, d equal to putting m and y removing here. Then result m cube minus m square plus 3m m plus 5 equal to 0. This is auxiliary form. After factorizing this, we get 3 values. M is m1, m2, m3. 3 roots are there. Then we write the formula for CF. Then you can solve this easily. On case 6, this question, problem, do yourself this, and similarly I have writing here one problem for practice, do you solve. This is based on case 6. D cube y over dx cube minus 7d square y over dx square plus 10 dy dx equal to e to the power 2x into sin x. This equation also can be written as, okay. So these two problems I have given for practice. You solve, same procedure apply in case 6. Then you get CF and PI. Both solution you can find easily of these problems which are given by us here. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.